Hey everyone, welcome back to another session in AP Calculus AB and BC course. And in this session, we will discuss few topics in Unit 4, which is contextual applications of derivatives. As you can see, its weightage is around 6 to 9% for the BC students and 10 to 15% for the AB student. If you need any further help or you want one-on-one tutoring sessions or regular sessions or group sessions, you can connect with us using this WhatsApp or Telegram number. Or if you have any doubt or you want to ask any other further detail, please feel free to connect with us on the comment box as well. So let's start with this unit 4. We have the following subtopics in the unit 4, which are basically related to rate of change. Okay, so we will see how we can apply it, right? We can use the differentiation for the motion related problems. By the way, non-motion related problems also can be solved using this. How it is going to give us velocity, acceleration. Okay, we will discuss that. So we'll start with the related rates problem or the rate of change problem. So for example, if we have dy over dx, which is basically the derivative of a function represented by f prime x. What that represent? This represents the gradient, right? Gradient of the function or the tangent line, right, at that point. Now it also shows the rate of change actually. That shows rate of change of y with respect to x. Like how y is changing if I am changing the values of x. Okay, so that is rate of change of y with respect to x. For example, if I have s as the displacement, okay, a function is given to us s as a displacement, which is a function of t, let's say f of t. Now if I take the one time derivative of that, ds over dt, what is that? Rate of change of displacement, velocity. So if I differentiate that function one time, I'll get the velocity function. And if you differentiate it one more time, and we know the rate of change of velocity is nothing but acceleration. So it means you can differentiate the velocity, or you can say double derivative of displacement, that is the double prime, that gives you the acceleration value, right? Okay. So let's discuss a problem on this. Question says, if a spherical balloon is being deflated at a rate of 5 cubic inch per second, at what rate is the radius of the balloon decreasing when r is equals to 5? So whenever you are solving problems related to rate of change, first step is always write what information is given to you. Okay, then what is to be calculated. Write these two first, then start solving your problem. So here it says a spherical balloon is being deflated at rate of 5 cubic inch per second. So cubic inch per second, what is that? It is the rate of change of volume with time. Cubic inch volume per second time. It means you are differentiating the volume with respect to time and it is deflated. Means it is decreasing, right? So I can say if my volume formula is right, we know that volume of a sphere is given by 4 by 3 pi r cube. Okay, so where r is the radius, and in this what we are given as, we are already given the dv over dt is nothing but negative 5. Also what we have to calculate, it says uh, at what rate is the radius of the balloon decreasing. Means r is the radius, we have to find the dr over dt value. What is the value of dr over dt when we plug in r equals to 5? That quantity is to be calculated. So now if I differentiate this function, I can find the dv over dt, where this v is a function of r and r itself is a function of t. So I will use chain rule, right? So let's apply the formula for the derivative. Here 4 by 3 pi is constant, so you have to take only derivative of r raised to the power 3, and using the formula, that is derivative of x raised to the n with respect to this x is nothing but n times x raised to the power n minus 1, and if you are using with respect to t. Okay, so here we have to use the chain rule, that gives us n x raised to the n minus 1, then dx by dt by the chain rule, right? In the previous session we did discuss this part. whether we are differentiating with respect to x or the same thing, or differentiating with respect to another variable. So 4 by 3 pi r cube, let's differentiate it. We get 4 pi r squared dr over dt. Now dv over dt is already known to us. Plug in that value over here. And let's calculate the value of dr over dt. Also take r equals to 5. So in the next step, I'll just substitute dv over dt as -5 and r as 5. And let's solve for dr over dt. It's simple now. Basic algebra, right? Simplify it. 5 cancelled. You get -1 is equals to 20 pi dr over dt, and using the cross multiplication we can find dr upon dt is nothing but -1 over 20 pi, which comes out as -0.016 inches per second, right? That's the rate of change of radius when radius is 5 inches. Answer. Next one. So next question is, it says if the position of the particle moving horizontally along the x-axis is given by this. Okay, so t is the time. As you can see, if you can also draw the graph of this. Okay, so the whatever be the graph is, that shows how the displacement or the distance displacement in this case is changing, right? Time with respect to time, t is the time. Now it first part says find the s1. What is s1? S4 and s5. So substitute t as 1 to get the s1. So let's find it. S1, replace t by 1. So I'll get 1 cube minus 10 times 1 squared plus 25 times 1. Just simplify it. Or you can plot the graph in your GDC if calculator is allowed for that particular question. You can plot the graph and you can find the y value for x as 1. Right? That also gives you the same thing. So here you can substitute this value and you can simplify it, and here what I'm getting, 25 plus 1, 26 minus 10, 16 is the value. So you will get the coordinates as 1 comma 16. What that represents actually, what is the interpretation of that? It means when the time is 1 unit, the particle is 16 units away from the origin in the positive direction of x-axis. So here you will get 16 units up. Okay, it is like this, 16 units up. This is horizontal distance and this is representing time. Okay, like this we can find the other displacements also for given time. For example, we have to also find the S4. What is S4? So simply replace your t by 4 in there and we will get our answer. Okay, so in this way I'll just write it now. So here I will get 4 cubed minus 10 times 4 squared plus 25 times 4. On simplifying it, I'll get the value as 4 simply. Similarly, I can write s of what, 5 also. Substitute 5 and you will get 0. What that means? It means after 5 seconds, the particle returns back to its initial position because displacement is 0 after 5 seconds, right? So it goes somewhere and comes back. Okay, so the total displacement is 0 as represents the displacement. Now, B part. It says at what time the particle temporarily not moving. If the particle is not moving, it means it stops at that point. Means the velocity, it becomes 0 at that point, right? So let's find the velocity and put velocity equals to 0 for this one. Velocity will become 0. And how can we find velocity? Take the derivative. Yes, we will take the derivative. S is already given. We will find the derivative of the velocity function. What is that? Now simply use the power rule. So yes, we got 3t squared minus 20t plus 25 by taking the derivative of this function, which is s prime t basically, which is our velocity function. Sorry, it is ds by dt, sorry, which is v. Okay, so we are taking the derivative of displacement function in order to get the velocity. Now I have to put velocity equals to 0. So 3t squared negative 20t plus 25 is to be substituted equals to 0, and we have to solve for the values of t from here. So it's a quadratic equation. If you want, you can use your GDSO for getting the roots, or you can factorize it. Okay, in both the ways you will get same answer. So when you factorize it, you will get a factor as 3t minus 5 times t minus 5 equals to 0. That gives me two values of t. They are 5 and 5 by 3. So at these two timings, the velocity will be 0, or the particle will be at rest temporarily for that these two timings only. Okay, for these two timings only. Now, next part, it says on what interval of the time is the particle moving backward. Particle moving backward. Here S represents what? Displacement. Displacement comes with a positive or negative sign. If it is positive, it means you are moving in the positive direction or in the same direction of reference, and if the displacement value becomes negative, it means you are in the backward direction, right? That much amount back from the initial position. So they are asking for on what interval of time is the particle moving backward. So it's very simple. Here you see we started with let's write it. These are 5 and 5 by 3, so let me write smaller value first. So I can, by the way, things are same, 5 by 3 to 5. Okay. So as you can see from 5 by 3, at 5 by 3 and at 5, the velocity is 0. Particle is at rest, right? It means between this time interval, that particle was moving in the backward direction actually. First, from 0 to 5 by 3, it was moving, let's say this is the original position, it was moving up, and when it reached at 5 by 3, time 5 by 3, it starts to come back till the what time? Till the 5 seconds time. And after 5, it again starts to move in the positive direction. Okay. So for that, what you can do? It's very simple. Take the sign for the V or S prime t. Make a graph for that. So plot these points 5 by 3 and 5. You know how to check the sign of S prime. Check the sign of S prime in these intervals. So take any value which is less than 5 by 3, and take a value which is lying between 5 by 3 to 5. Take a value which is more than 5 and put it in the S prime. Okay. It's totally up to you which value you want to substitute. So here in this expression, put any values of time. For example, you can take time as say 1. Okay, put 1. So you will get the sign in this interval. So when you do it, put time t equals to 1 over here, and as you can see, I'm getting 28 minus 20 means 8 positive. Similarly, if you choose a time from 5 by 3 to 5, any time, okay, let's take 4. So when you take t equals to 4, the velocity will become negative in that region. So negative means it was moving backward. Similarly, for any value which is more than 5, take 6. It's your choice, any number greater than 5. So let's say 6. So you will find it is positive. So positive. So hence I can say positive, negative, positive. So during this 5 by 3 to 5 seconds, the particle was moving backward. Obviously, the particle was moving backward for this time 5 by 3 to 5, the particle was moving backward. At 5 by 3 it becomes 0, the velocity, and at 5 also velocity will become 0. So in this way we can find the intervals. Okay. Now if they ask for finding the acceleration, okay, I'm just adding one more question by myself. This is find acceleration at time, let's say 4 seconds. Okay, so all you have to do is just differentiate the velocity one more time. You already have the velocity function with us. So acceleration will be derivative of velocity, and at the end we have to substitute t equals to 4 in that. So here we got what? It is 6t minus 20. 60 minus 20 is the acceleration at any time t. But specifically, if we have to find the acceleration when the time is 4 seconds simply, so put time as 4. So we got 6 times 4 minus 20, which comes out as 4. So here we got the acceleration value also. Simple. Okay. So in this way, you can try out these questions as you can see on your screen. Okay. And if you find any difficulty or have any doubt in these, feel free to connect with me. Later, we will discuss how can we use the integration, because which is anti-derivative actually. Okay. And we can again find the acceleration values to velocity, right? If acceleration is given, we can find velocity by integrating it. If velocity is given, we can find displacement by integrating it. So they are related. Okay. So that's it for this session, and I hope you got these. And today we covered these rate of change related problems and straight line motion related problems. Okay. And we have already seen rates of change applied to the context other than the motion by that inflation and deflation of balloon problem. Okay. So thank you for watching this session, and I'll see you all in the next session. And if you have any doubt or want to connect with us, you can contact us using this mobile number. That's it for this session. Keep watching, keep learning.